Hi, ladies and gentlemen, boys and girls, wherever you are 100% welcome. Right, as you remember in the previous videos where you were introduced into a topic about the trigonometry, we are now in the tip of it. Let's finish together by looking at the last sections of the topic. Here we are. We would like to conclude everything about the angles of depression and the elevation, and then immediately we're going to jump into the last section of the topic, that is about the bearing. All these are areas which are very crucial in exams, where exam questions might come. They might not be direct, as I said. So now let's finish about the depression. That time in the previous video we talked a lot about the elevation. So here, as usual, I will not have several examples, just one is enough, where you give you a guide, because as we indicated that time, elevation and depression are almost the same. I have one problem. Right, so take note of this, where possible, you can copy, and more importantly, if you're copying all these questions as I've been requesting you, I think that's a good show, because it will need you to revise them, and every time you'll be updated in such way. Right, so what we have here is just a real life situation where we can really see that issues about trigonometry are applied, because you don't just have to learn the concept without knowing the motive behind it. So here we are. The question goes like this, and you meet similar situations in the real life situation, and you need to apply the knowledge about trig. A woman 1.5 meters tall. We are told she's standing on the top of a cliff, which is 30 meters high. But this woman, we are told she's looking down on a boat that is on a lake. If the boat now, we are told, is 80 meters from the base of the cliff, we are asked now to find the angle of depression of the boat from the woman. See, now we are now on the shore of the lake. Where we are, we need to apply issues about what we're doing in class. So as I earlier indicated that these problems most of the time, they are work better if you produce a diagram that represents the entire information in the question. So like here, what I expect you to do is at least bring in the realistic situation that somewhere we've got a cliff. This is just like a high ground that is along the lake. So for instance, maybe if I can draw something, a real situation on the ground, we should expect maybe to have a lake, which is this one here, right? Let me just take that this one is a lake, body of water. And usually the lake is surrounded by a certain body of land. So this is the land, and very steep on the side of the lake, and the one that is known as a cliff. It happens sometimes some of us are not geographers, so we need to know what a cliff is. So high ground along the lake, which is very steep, like that one. So just like here on top of it, we have a woman. So let me just draw a resemblance of a woman like this one here. Right, so we talk of height of woman, we're referring from the foot up to the eye, because the issue about what we're doing here is relating to the sight of a particular individual. So that's it, she's on a high ground. Down here, there's a lake, and there's a boat on top of it. Here is a boat, right? So that is your boat, a situation, the ground. So she's looking at the boat. So you can draw the line of sight represented by this one here, like this. So you can take that this is the line of sight of the woman. Normally, in the normal circumstances, if she's not there interested to look at something else, or maybe something interferes with her, we should expect that she should always have her sight always in the horizontal line, like this one here. So originally, we have to consider that each time we talk about these angles of elevation and depression, we take it for granted that the person or anything that has got a sight is always having the sight in the straight line. So this is a normal line of sight. But now she's interested to look at the board, so she has to twist her head down like this, right? So in so doing, you may find that the two lines, normal line of sight and the new line of sight that she is using to see the boat, the two are able to form an angle. So here, this definitely in the question, when you could hear something about the angle of depression, it means definitely what will be asked here to wake up on is this one here, angle of depression of a boat. Right. So what information are we given here? They were told that the cliff is 30 meters high. So here we're considering issue from the base of that is now the top of the cliff. Like that's on top of the lake, top of the surface of the water on the lake, not necessarily on the bottom of the cliff, but now we are referring it from here against the level of the water because it's where we have got the boat on top. Right. Now it means from here to that is 30. So you can take this one at 30 meters, but a woman is 1.5 meters tall. That is to say, from the foot up the eye, that is 1.55 meters. Right. But the boat is 80 meters from the cliff. So it means from here up that the distance referred to 80 meters. So now when we talk of the height of a boat, of the cliff here, definitely we're referring to each that is the height that is perpendicular to the ground level. So we talk of the height of the cliff now is perpendicular to the surface of water. So usually now when you come to class, this is just a realistic situation. We should expect here to have a light angle. So it means this height of a woman plus the cliff to the surface of the water, that one should be a perpendicular distance. That in normal circumstances, if we are to work out the problem here, you can represent a line that is connecting the height of the cliff and the woman. Right, so it means everything that will take up from there, will just take a line like this one. And the surface of water is also represented by a straight line, which starts from here up to that. And then in the side already drawn a straight line, normal side already drawn a straight line. So end of that side, if you find that you are already there in what we have been discussing, that is the issue about the right angle triangle. So it means whatever we do here is about the trigonometry, which is going to work that involves the right angle triangle. So from the question here, they say, can you find the angle of depression of the boat from the woman? This is the angle of depression. I earlier indicated that the angle of depression, that angle that you use to see something that is down. So be able to see that that is the angle. Right. So somewhere again, I also gave you the relationship that is there between the angle of depression and elevation. That is to say, if maybe you are there at the boat, you should be able to see this guy, this woman on top, and you need to twist your head upward like that. So as you twist your head upwards, then this is now your angle of elevation. So in this case, since there's a common line of sight, we should expect to have angle of elevation being alternate to angle of what? Depression. So you're just as good as in the attempt to work out to this one, you can just work out of this angle here. You work out the angle of elevation is as good as finding the angle of what? Depression. Right, so in short, let's just take that we have to find the value of this angle here. Once to find this, we should expect that this one is alternate to that. Then once to find this one, it means it's equal to that one. This one is elevation, this is depression. Right, so you should first of all analyze the problem before you start solving, so that it should always be accurate. Right, so now what do we have here? So what we have here is a situation that is like this. Now in class, you have a line connecting a lady here and the distance of the cliff from here up that. If I can call this one as E, this is D, so I'll talk of ED. It's the height connecting the woman and the what? The cliff. So it means the total distance here is 30 plus 1.5 meters. Right, so here, mathematically, it means I'll draw my line like this here. Right, that is from here up that. And then now have the situation on the ground, the surface of the water. And here is the boat, presented by B here. And here is the surface of the water where we have got an estimation of the distance of the cliff and the woman. Up here, we have got E, just representing the eye. So in normal circumstances, line of sight from the eye to the boat looks something like that. Right, so the target is to find the value of this angle here. Right, so in real life situation, we are targeting this, but rather let me just maybe present this one by x1, so I can still more take that this one is x2. So when I find the value of this angle, it's as good as finding that, but the target is finding that angle there. So this is 90 degrees light angle, And this one, distance from D to B is 80 what? Meters. Right. So what do you have then? What about from here after that we are given that say this is a connection of two parts, one for the cliff, another for the woman. It means the total distance here, it should be a total of 1.55 plus what? That is what? 30. So it took over 30.00. That's what it means there. So you have got 31.55. So distance from here to that is now 31.55. Right. So we are targeting at finding the value of angle x2. Right. So to make it well understandable to you, when you are working out such problems, still have to give us the guide that exactly what is it now we are going to do here. So here we're going to tell us to say the required angle that we need to work here is angle what? Angle x. Right. So here I'll take it for you to say, suppose we are supposed to calculate or say find D. That is angle what? X2, which is the same as x1, x1. This is elevation, this is depression. I find elevation is same as depression because the two angles are alternate. Remember what I said, that line is parallel to that. Right now, so from what I said, this is about trick. You'll be in the position that's now to sit down, then try now to figure out, say, in the Sokatoa, what ratio should I take? And use to work out the value of that angle. Right, so I gave you a guide to say, if you like to find the value of the angle, try to determine the name of the sides of which values are given of the triangle. Right, so like here, in relation to this angle here, you need to know what name is given to this side. We're given here DB and side what? DE. So you'll be able to appreciate that the side DE is opposite side to this angle x2, and the side DB is just adjacent side to angle x. So from the three ratios you have, you'll be able to see that it is only time that involve the use of the opposite side and what? Adjacent side. So it means definitely here in the Sokatoa, we're going to pick the last three sets of letters. Remember we indicated to say so, ka, toa. Right. So opposite and adjacent gives you the tan ratio. These others opposite adjacent, so hypotenuse, opposite hypotenuse. Right, but here adjacent hypotenuse. So we'll talk of the last set of letters. Tan is opposite over adjacent. Because opposite side is given, adjacent side is given. So please do not memorize and don't rush. But please pick up the guides. What am I supposed to do? I meet such type of situations. What's more crucial here to choose ratio? What ratio should I take? Right. So straight we go to tan. So here light I indicated as say tan of angle x2 is equal to opposite over adjacent. So light here say 31.55 over 80. Right, so that the two sides are related in the ratio. Right, so thereafter, make life simple. Take a gadget, that is your calculator, and divide the two. You'll be able to find that the value of which you get the 3.3 is just equal to 0. What? That's a 3944. Right, so the ratio is now represented into the what? Decimal fraction. So to work up the value of that angle, it means this angle is in here. So you're supposed to get the inverse of which. So what you have there, you need to get the tan inverse of 0.3944. Using a calculator by all those steps, second function, then press tan, be able to see that symbol is existing, and they enter this number here is 0.3944 on the calculator, and be able to find out the value of the angle there easy into 1.5 degrees, which can be expressed into nearest whole degree, and this is 22 degrees. So which means this one is 21.5, or nearest degree is 22, then this one is also 22. So this is the angle of depression. Then conclude and say, therefore, the angle of depression is equal to 22 degrees. We're done. Right, so that's the way it is about this section. Bearing, not bearing, but over elevation and what? Depression. So please let us now leave this section out. what you should just be doing, just focus on the revision, do the revision, replay the videos now and again, that you master the concepts. Fine, now let's jump into the last section without wasting our time. We need to finalize this topic. Right, so we are going now to bearing. Right, so I want to introduce you in this one to bearing, and after in the last two videos that we have, we're going to discuss more solving the problems, what type of problems should I expect to do, things like that. But now here, let me introduce the bearing, having heard everything about the revision and depression. Right. So all these two sections are just applied sections of the trigonometry, and these are the areas most questions will be coming, because usually this time around the questions don't directly find this angle, you're given a triangle, very rare, maybe in paper one, but now we have to explain things which are applied. We learn in order to apply principles. Right, so here we are, bearing. Right, last section. All right, let's define what bearing is. What is bearing? Geographers are already there. They have some kind of already some kind of explanation about it. They know A, B, C, D and like. Right, but somewhere as mathematicians, let us get the detail of which. Right, so before I define it, I would like first of all to discuss this with you. Right, bearing is all issue that is related to direction. So I'll first of all discuss you about direction, so that when I will talk of bearing, you should also be able to know what type of direction is it. Because if you talk of direction, we have got our own expectations in the life. So if you talk of direction, we'll be talking of such things like north, south, and the like. If something is found on this direction, you'll be able to go by that. But now if you say bearing connected with direction, what is it about? Right. In normal circumstances, when there are human beings interacting, each time we talk of the direction of the press, remember I'll be brief here. It's not geography where I teach. We are there referring to issues about the cardinal points. Right. You know the device, the compass. This device that's got a north-south line like this one. This is the north direction, this is the southern direction, and here we have got the east-western line like this one. Like this is an eastern direction and this is a western direction. When you go to this side east, so this side west, you go up north, down here is south. Right, so the two lines usually they intersect at the right angle. Here is 90, here is 90, again here is 90. Such that in the normal circumstances, if we are there to find the total sum of the angles at which these two lines are intersecting, you'd expect to have got four right angles, 90, 90, 90, 90, and that gives you 360 degrees. Right. So if we talk of the direction of a particular place or a position of something in relation to the other, we most of all use a pair of circumference, a device that have got such types of representation. Two main lines, north, south. So that when I go up northwards, I go this side westward, I go that side eastward, I go downwards southwards. Thus, it is about the direction of a place. So in maths here, we're also about that. Right. But now if we sometimes, I'm not going straight within that line. I'll be talking of, say, within the 90 degrees, within the 90 degrees, either within this 90 degrees, it can be between south and east, or between north and east, or between north and west, or say south and west, in between these 90, the right angles there. The direction of which, any direction that you take in between those two lines, we are saying that that position of a particular thing is found by description of those cardinal points. But now they're going to name two things. Like here, if I go maybe anything that is within this quadrant here, you'll be talking of the direction here is to the northwest direction. But now if you are maybe within this quadrant here, still more the position there is the northeastern direction. And down here, look at this other quadrant. it is within the south and east. So any location within that is described with the direction of what? Talk of southeast. We don't have east-south, no, but we begin with always with this main line here, north-south. So we talk of the anything within this quadrant here is found at southeastern direction. Either you are here, southeastern direction. You are here, southeastern direction. Northeastern direction, northeastern direction aside. And here again, northwest, northwest. Right, so such kinds of terminologies to say is on the northwestern direction. This is northwest, this is northwest. But for the west, it's definitely against the right angle is the 90 degrees. But you talk of the east, it's 90 degrees. But you talk of the south, it's just 90 degrees. Something's found in the north, it's 90 degrees right angle. But now in between here, just say this one, maybe talk of the P is found in the northwest, K is found in the northwest. Somehow it's not specific. So as mathematicians want sometimes to be always specific in the direction of the place. Don't just say northwest, it's southwest. Exactly where? So to be specific, we're using the angles to identify the exact position of the place. So within here, within the same, the north, south, and also west, east, we are now involving the angles that will always give you the specific position of what? Of the place. Suppose you find that here within the northeast, you have got a position of a place which is exactly at 45 degrees. Against the angle which is just like the half of the 90 degrees is also going to tell us that the position of this particular place is found on the north 45 degrees what? East. That is specific. So it means somewhere, if talk of the position of the place is just position of P is found on the 45 degrees northeast, then you'll be talking of an angle from there against the line that is heading towards what? That place. Right, because if you just say northeast, this is too wide. Right, so the use of angles here in describing a specific position of the place that is regarded as what? Bearing. It gives us the issue of this bearing. So since now we're talking about the angles, now specifically to define what bearing is, we can just talk of the amount of 10, which is an angle in this case, giving us the specific direction of what? A position of a place. That's it. So the bearing here, to define it, you can just talk of as the amount of tan. That gives us a specific position of a place. Right, so that's it about the bearing. So next, as we'll be going in the other video, we are there now going to discuss on how best we can use such angles to define a position of the place. Like you have mentioned, talk of 45 degrees northeast, it means you are going to turn an angle like this one at this if exactly P on the angle 45 degrees. So in that case, it means you are telling us this angle is what? 45 degrees, like that. Unlike if maybe that somewhere is here, it's also on the northeast, maybe this one is found on the what? Talk of 50 degrees. Now it means a particular space here, talk of that, maybe talk of any. That now it means it's quite different from this. But area, you just talk of the northeast, that does not make sense. But talk of, say, if this angle is 50 degrees, you talk of N is found on the what? No, we talk of the 50 degrees northward, east, to be specific. Right, so at the moment, let me first of all stop here in this video. Right, so that in the next video, we'll just pick up from what we have done. We'll discuss how to define, to come up with the bearing using the angles, and then 2-3 examples will be done where we can apply such type of what? Concepts. Right, so please stay put and be able to open up the next video that we have very soon. Thank you very much for the meeting at the moment.